Hey there, and welcome. You know, when you hear machine learning, it's easy to think of some sci-fi movie, right? Robots, a far-off future. But here's the thing. It's not the future. Not at all. It's right here, right now. And it's a huge part of your life, probably in ways you don't even realize. So let's dive in and really unpack what's going on with one of the most important technologies out there today.
I mean, think about it. You probably used it like a dozen times before you even finished your morning coffee. Asking your phone for directions? That's machine learning figuring out what you said. Using an app to translate a menu? That's ML. Or how about this one? Typing beach into your photos and boom, all your vacation pics pop up. Yep, you guessed it, that's machine learning too. It's this quiet engine humming along in the background, powering all these little features we totally take for granted. It's basically magic in your pocket.
Okay, so we've established it's everywhere. But that just leads to the real question, doesn't it? What is actually going on here? What does it even mean for a machine, a bunch of code, to learn? It sounds kind of human, but the truth is, it's both way simpler and, honestly, way more amazing than you might think.
So to get to the bottom of this, here's what we're going to cover. First, we'll talk about what learning even means in this context. Then we'll do a little showdown, the old way of doing things versus the new way. We'll look at how these machines get smarter all by themselves, and finally, why this is such a huge deal.
All right, let's jump right into the deep end. What does it really mean for a machine to learn?
Okay, before we get to the official definition, let me ask you something. Let's say you download all of Wikipedia, the whole thing, on your computer. Your computer now has a ton of information, for sure. But has it actually learned anything? Is it smarter? Nah, not really. It's just a digital filing cabinet. It can't connect the dots or figure out something new from all that text. It's just holding it. Real learning? That's a completely different ballgame.
And that brings us to the OG definition, all the way back in 1959 from a pioneer named Arthur Samuel. He said, machine learning is what gives computers the ability to learn without being explicitly programmed. And that phrase right there, without being explicitly programmed, that is the whole game changer. It's the move from telling a computer every single tiny step to just giving it a goal and saying, all right, you figure out how to get there.
Fast forward a few decades, and a computer scientist named Tom Mitchell came up with a more formal, nerdy definition that everyone uses today. Now, it sounds a little academic at first, but stick with me because it's actually brilliant. He said, a program learns from experience E with respect to some task T and some performance measure P if its performance at the task, measured by P, gets better with more experience. Okay, I know, that's a mouthful. Let's break that down right now. So it really all comes down to these three things: task, experience, and performance. T, E, and P. Let's make this super simple with a spam filter. The task, T, is easy. Figure out if an email is spam or not spam, which, fun fact, people in the field sometimes call ham. The experience, E, is just a boatload of example emails that humans have already labeled. And finally, the performance, P, is how we check its homework. Are you getting it right? What percentage of emails are you classifying correctly? And here's the kicker. If that percentage, that performance, goes up, the more emails it sees, then boom, your program is officially learning.
Okay, so now we know what learning is. Let's really see why it's such a big deal by pitting it against the old school way of doing things. It's time for a showdown. Rules versus data.
All right, first up, the classic approach. This is how we used to solve problems like this. A programmer, a real person, would have to become an expert on spam. They'd sift through thousands of spammy emails looking for clues, and then they'd start writing rules. A whole bunch of if-then statements. Like, if the email has the words free money, then it's spam. Or if the email has a bunch of weird links, then it's spam. And it's this endless cycle, right? You write some rules, test them out, see what you missed, and go back to write even more rules.
And you can probably see the problem here, right? This gets crazy fast. The spammers get smart. They start writing prize with a 1 instead of an I. Well, you got to add a new rule. Then they write free with a 3. Guess what? Another new rule. Before you know it, you've got this gigantic, tangled mess of rules that's an absolute nightmare to keep track of. And every single time the spammers change their game, a human has to go in and fix it. It's this constant, exhausting game of cat and mouse, and you're always one step behind.
But now, let's check out the machine learning way. This is where everything changes. Look at the flow here. That second step, write rules, it's gone. It's been replaced with train ML model. So instead of a human trying to guess all the possible rules, we just feed the machine a ton of data, that experience we were talking about, and the algorithm finds the patterns all by itself. It's a total flip.
So here you go, side by side. This is the big idea. The old way, humans had to handcraft all the rules. The program was static. It only knew what we told it. But with the ML approach, the program learns the rules from the data. It's dynamic. It can adapt. And what's really cool is it can find patterns that a human might never, ever notice. That is the revolution right there.
So when we say experience or training data, what does that actually look like? Well, it's pretty much this. It's just a big table, really. You've got a column with the email text and another column with the right answer, the label, spam or ham. The machine just goes through millions and millions of these rows, and it starts to figure out the subtle connections between words and patterns and whether something is junk or not. It's literally learning from examples, kind of like how we learn when you think about it.
But wait, it gets even better. The magic isn't over just because the first training session is done. See, one of the coolest parts of machine learning is that you can build systems that just keep learning. They get smarter and smarter over time.
Check this out. Once the system is live and doing its thing, you can set up a feedback loop. So when new data shows up, like every time you hit the Mark as Spam button on some new junk email, that example can get sent right back to the system. The model can then automatically retrain itself with this fresh data, so it learns the spammer's latest tricks on the fly. No human has to step in and write new code. It just happens.
And that, right there, is its superpower: automatic adaptation. For problems where things are always changing, think spam or credit card fraud or predicting the stock market, a system based on fixed rules is going to be obsolete in like 5 minutes. But a machine learning system, it can evolve. It keeps itself up to date because it never stops learning.
Okay, so we've talked about the what and the how. Now let's get to the big one, the so what. Why does any of this matter? When do you actually want to pull out this powerful tool?
Well, machine learning really shines in a few specific situations. First, for anything that would normally need a massive, messy list of rules, like our spam filter. Machine learning just cleans all that up. Second, it's for the really hard problems, where we don't even know what the rules are. I mean, how would you write rules for speech recognition? To turn sound waves into words? It's basically impossible for a human to write that code, but a machine can learn it. Third, as we just saw, for any situation that's constantly changing. And last but not least, for digging up amazing insights from gigantic piles of data.
But here's a really cool twist. Machine learning isn't just about building smart machines. It's also about making us smarter. Think about it. A model sifts through millions of data points and might uncover a pattern that no human would have ever caught. We can then kind of look inside the machine's brain, see what it learned, and gain a totally new understanding of the problem ourselves.
And this whole idea has a name. It's called data mining. You're basically using machine learning as a discovery tool. You can point it at a mountain of data, sales numbers, medical records, whatever, and it acts like a super-powered detective, finding these incredible hidden patterns that were just buried in all the noise. It's a tool for pure insight.
So, let's wrap this up. We've seen that machine learning is this huge shift away from writing hard-coded rules and towards learning from data. It's powerful, it's adaptable, and it's great for automating tasks and for discovering new things. But that brings us to one last really important thought. The whole system is based on the data we feed it. The machine only learns from the examples we give it. Which leaves us with a pretty big question to think about. If these machines are learning from our data, what exactly are we teaching them?